Today we're going to start a new chapter, and we're going to talk, our new chapter is going to be on sequences and series. So sequences here, we just have, that's like a list of numbers that we're listing out. What series is series is some sort of sum. So I'm going to write a couple here down. Let's say we have 8, 3, -2, -7. So here's our first sequence. We might a second sequence, 1, 1, 2, 3, 5, 8. And a third sequence, let's say we have 3, 9, 27. And these sequences keep on going. So if we were to look at these, this first one you might say, oh, I see a pattern here. I'm subtracting 5 each time. So if you are subtracting or adding, we call this one, it has a common difference. And our common difference is -5. And we call this one arithmetic. Now when I look at these, the second one I'm having a tough time, but this one I'm seeing times 3 times 3. So this one has a common ratio of 3, and we would say that this one, since it's multiplying, it's geometric. And now this middle one, some of you guys might recognize it. 1, 1, 2, 3, 5, 8. It's pretty famous. It's called the Fibonacci sequence. And to get it, we add the previous terms. So if, for example, 1 and 1 makes 2. And then if we were to take 1 plus 2 is 3. 2 plus 3 is 5. And then we could keep going. So this one is neither arithmetic or geometric. But what we're going to look at today is we're going to look at how you write these as recursive formulas. And recursive means you're using the previous term. And you always have to say like what the first term was. And some of you guys might remember this from last year. So letter A, and I'm going to show you a couple different ways it's writing. Sometimes you write the notation with different letters. It doesn't matter. But you always say what the first term is. So I'm going to say the first term is 8. So this notation here means first term, and we're saying it equals 8. So then what we do is we say to get any term. So to get any term, we'd need the previous term, so f of n minus 1, and we are subtracting 5. And again, you might see some different letters. So this means you take any, to get a term, you take your previous, and you subtract 5. So the second one here, let's see, we got to say what our first term is. So our first term is 1. And actually to get any term, we have to know the first two. So we'd say f of 2. The second term is 1. And then our recursive, so to get any term, we add the two previous. So f of n minus 1 plus f of n minus 2. So that one's a little trickier because we have to use the two terms before. Let's try that last one, and I think you might see that this is a little bit easier. So again, our first term is 3, and then to get any term, we're multiplying it by 3. So we'd say 3 times our previous term, f of n minus 1. So let's see if we can just try one here. What if I said, write a recursive for 20, 18, 16, 14. Well, I'd look at that and be like, this one's easy. It's subtracting 2. And I'm going to show you sometimes it's not F. You might see it with sub-letters. So you might also see it like F sub 1. So that means the same thing. This just means our first term. And then we write to get any term, instead of f of n, you'll see it as a sub n equals our previous one, and we subtract 2. So again, this just means our term equals our previous minus 2. So let's see here. I'm going to give you a sequence, the rule, and I'm going to see if we can write out the sequence. So, for example, let's say you have f of 1 equals 8, f of n equals f of n, whoops, that didn't turn out, n minus 1 plus 11. And you need to find f of 6. So it's saying find your sixth term. So sometimes it helps to make a table here. So our first term, second, third, fourth, fifth, sixth. So we know our first term here is 8. And what do? We take our previous and we add 11. So 8 plus 11 is 19, plus 11 is 30, plus 11 is 41, plus 11 is 52, plus 11 is 63. So we have our term. And again, you might see this with some different notation. So let's say I said your first term equals 2. And to get any term, you take 2 times your previous, and you add 3. So this is saying 2 times your previous term, and you add 3. So again, I like to make tables for these. So first term, second, and let's say you want to find, let's say your goal is to find a sub 5. So your third term, fourth, fifth. So our first term is 2, and it says 2 times your previous plus 3. So to get the second term, 2 times 2 plus 3, so that gives us 7. So to get the next one, 2 times your previous of 7 plus 3, 14, 15, 16, 17. 2 times your previous plus 3. So that's 34. And let's see, 34, 37. So 2 times 37 plus 3. So that's 7. Whoa, sorry guys. So 2 times 37, 74 plus 3 is 75. Feel like, I forgot to put 34 in there. Okay, I was going to say this got really big really quick. Let's see, 64. That's not right. 2 times 37, 60, 74. Plus 3 is 77. So we have our fifth term there being 77.